and welcome to this meeting of the Science Alliance.
And I'm Judy. Today we'll be talking about something you can't see, although it's all around you.
And while we can't show it to you, we can show you what it does. It's energy.
And let's get right to our first question.
Our first question about energy is from Peter. What is energy?
To answer Peter's question, we'll have to do some investigating. Let's look at energy being used. They were all examples of energy at work. Let's take a closer look. The wind is pushing on the blades of the pinwheel and turning it. Electric motors push on all the rides to make them move. Mrs. Woffenden's foot is pushing on the pedal to make the spinning wheel turn. The horse is pulling on the wagon and moving the driver along the track. Steam is pushing on the piston of the steam engine, which pushes on the wheels and makes them turn. The drummer's foot is pushing on the pedal, so the drumstick hits the drum. Gravity is pulling on the cars of this ride and moving them down.
Scientists say that energy is the ability to do work, moving something. All of Judy's examples showed energy pulling something or pushing something.
That's right, Rex. Energy makes things move.
Barry asks our next question. He wants to know, can energy be stored?
In the examples of energy Judy showed us, we were looking at energy in motion. But there are many ways that moving energy can be stored to be released at a later time. Right now, I'm storing energy in the spring of this toy. The toy isn't moving now, but when I let it go, the toy moves as the spring unwinds. It's using the energy I stored in it. Here's another example of stored energy. Electrical energy.
Madalena is storing energy in the balloon. When she lets it go, the energy is released and the balloon moves up the string.
Here's another way to store energy, by lifting something. Sam and Andrew are using energy to lift the water, and some of that energy is being stored in the glass globe. When the button is pushed, the energy is released and makes the train go. Energy can be stored.
Stephanie asks our third question. Where do we get most of our energy?
We get our energy from a number of different sources. But our greatest source of energy is also our closest star, the sun.
I was wondering when you would finally say my first word. And now it's time for Bryant's Giants of Science. If you were to travel at 100 kilometers per hour and headed straight for the sun, it would take you 171 years to reach it. you would see a huge ball of gases producing large amounts of heat and light energy. At its center, the sun is more than 50,000 times hotter than the hottest kitchen oven. The sun's energy, also called solar energy, travels away from the sun in all directions. The Earth is in the path of a very small part of this solar energy, which takes a little more than 8 minutes to get here from the sun. Even this small amount is enough to heat the Earth and give it light. The light energy from the sun is important to the growth of plants. The green part of a plant, called chlorophyll, acts with sunlight, water, and a gas in the air called carbon dioxide to cause the plant to make food and to grow. The heat energy from the sun is responsible for our weather. Without the sun, our planet would be frozen, dark, and lifeless. Bryant salutes our nearest star, the sun, our greatest source of energy and a true giant of science.
As I was saying, the sun is the Earth's greatest source of energy, solar energy. Here's a question from Bill. He wants to know, how can we use solar energy?
You can find out for yourself. You can use a lens like this to concentrate the sun's rays and change the sun's radiant energy into heat energy. There are other ways to tap the sun's energy. A solar reflector can concentrate the sun's radiant energy and produce enough heat to make a motor turn. Solar energy can also be stored to be released at a later time. Have you ever seen stored solar energy? Here's some: wood. Trees collect solar energy. As Bryant said, sunlight works with chlorophyll, carbon dioxide, and water to produce food and make the plant grow. The more the tree grows, the more wood it produces. One way to release the energy stored in wood is to burn it. The stored solar energy is released as heat energy and light energy. Here's another food made by a plant. It's a fuel, just like wood. Right now I'm releasing the energy stored by the plant that made this. But of course, you'd rather eat a peanut, wouldn't you?
Did you say peanut?
Yes, I did, Bryant.
Why, thank you. That's my second word. And that means it's time for Bryant's Giants of Science. About 100 years ago, farmers in the southern part of the United States were having problems raising their crops. Cotton was a difficult crop to grow, and they couldn't produce enough to make it worthwhile. George Washington Carver was a scientist who studied this problem and suggested to the farmers that they try a new crop: peanuts. That's monkey food, protested the farmers. And anyway, no one will buy our crops. Yes, they will, Professor Carver explained, because the energy from peanuts can be used in many different ways. He had been doing experiments and found over 300 uses for peanuts. To demonstrate some of the possibilities, Professor Carver prepared a special meal at the university. After all the guests had eaten the soup, creamed mock chicken, bread, salad, coffee, candy, cake, and ice cream, they were told that their entire meal had been made from peanuts. George Washington Carver had proven that there was a use for all the peanuts the farmers were able to grow. Today, peanut energy is used to make peanut butter, cooking oil, margarine, paint, soap, explosives, paper, and many, many other things. Bryant salutes George Washington Carver, the scientist who found many uses for peanut energy, and truly a great giant of science.
Thanks, Bryant. So you see that the solar energy stored by a plant can be used in many different ways.
Or it can be stored again to be released later. When you eat, your body takes in the energy of the food and stores it in your body until you release it to do some work. Solar energy can be stored for millions of years before it's released. This barbecue produces heat energy when it burns gas. Gas is a fossil fuel.
oil is a fossil fuel too. Millions of years ago, trillions of tiny plants and animals sank to the bottom of the ocean when they died and formed great mounds of animal and plant matter. Soil covered and mixed with this material and formed layer upon layer. Tremendous heat and pressure chemically changed these layers into oil and natural gas. After a long time, the oil and gas tried to move up to the surface of the earth, but much of it was trapped under layers of rock thousands of meters under the ground. Today, people take these fuels out of the ground so that we can release this solar energy stored for millions of years. Coal is a fossil fuel formed from plants that lived millions of years ago. Today, we release this stored solar energy when we burn coal to generate electricity.
This cell also generates electrical energy. It changes the radiant energy of the sun into electricity. These pictures were taken by cameras powered by light from the sun. Solar cells produce all the electricity necessary for astronauts to live in outer space for long periods of time. So you can see the many ways that solar energy is used.
Here's our last question. It's from Heather. She asks, why should we conserve energy?
We told you about the sun, our greatest source of energy. It's continuously working, producing energy from itself, and it will continue to do so for millions and millions of years. But the energy most used by people today is the energy of the sun stored in fossil fuels. And we have to learn how to use these fuels wisely. It took millions of years for the sun's energy to be changed into coal, oil, and natural gas. Much like the marathon runner who has to learn how to pace himself. He has to learn how to have as much energy at the beginning of the race as at the end. We have to do the same thing when we're planning a barbecue. After all, we can't have all our food gone before all our guests have had their share. Someone once figured out that our fossil fuels on Earth will last for only a few hundred more years. What will we use for energy then?
Well, already people are studying ways to use energy that will replace fossil fuels. Many years ago, people harnessed the energy of the wind in windmills. Perhaps wind generators will become more common in the future. The force of moving water is being used in many parts of the world to produce hydroelectricity. And the sun's energy is being tested to see if it can produce enough energy in large solar furnaces. Maybe one day all homes will be equipped with solar heaters to save the sun's energy for use at a later time. We should learn to conserve the energy we do have, replace the sources of energy we use up, and continue to search for sources of energy not yet dreamed of.
There are many more things you might like to find out about energy.
Before we see you at our next meeting of the Science Alliance, find out all you can by experimenting, reading books, and talking to people. Bye.
Bye-bye.